Now, let's look at the question 26 here. Here we are given the number and we want to find out the number in standard form. This is a scientific notation. By the fact we have talked about in the previous video clip, we know 5.58 times 10 to the 6th power is simply shift this decimal point 6 times to the right. So then you know 5.58 times 10 to the 6th power, you simply do is shift this decimal point 6 times to the right. It was here, so you go 1, 2, 3, 4, 5, 6. 6 digits. That's it. Very easy. Now, here is 10 to the negative 5th. Then you shift this decimal point 5 times to the left-hand side. That's it. So it was 4.4. Here you do 1, 2, 3, 4, 5. 5 times. And it basically tells you there are 5 zeros in front of 4, including the zeros before the decimal point. Okay? So that's the way we do it. Now, 28. 28, we are given one scientific notation number times another one. We want to understand what's the meaning. 6.7 times 10 to the negative 2 is actually 6.7 divided by 100. 6.2 times 10 squared, we know 10 squared is 100. 1 here is negative 2, then you put this 100 downstairs. That's it. Negative goes to downstairs. Positive, that's upstairs. Everyone knows 10 squared is 100. Okay. Then upstairs 100, downstairs 100 can be cancelled. So what you get is 6.7 times 6.2. You hit your enter. 41.54. Which one is that? 41.54. That's the one right here. The one here. Okay. And there is nothing to do with this. This one might be correct for scientific notation, but it's not in the normal standard expression. Because here, negative 2, positive 2 added together, it is 0. This will make, but this is not in the standard. It has to be in this way. Okay. Now, 29. 29, we know 2 times 10 squared. That's 2 times 100. 7 times 10 cubed, and we know 10 cubed is 1000. So here exponent is 3, you have 3 zeros. 10 squared, exponent is 2, you know that's 2 0 after 1. So basically, the number of exponent tells you how many zeros behind 1. 3 tells us 3 zeros behind 1. And then you know 100 times 1000, then you should have 5 zeros behind 1. Because this number 1000, if it were times 10, you add 1 zero. Times 100, you add 2 zeros. And we have 5 zeros behind 1, so we do 10 times fifth. 2 times 7 is 14, but this is not scientific notation. For scientific notation, it has to be no zero digit before the decimal point. So we know 14 is 1.4 times 10, and then 1 times 10 to the fifth, you simply add the exponent for 10 is 1. You simply, here is 1, here is 1, here is 1. Okay? So you simply add 1 and 5, you got that. Okay? So it's also like 10 times what? 10 times 100,000. You actually get 1 million. 10 to the sixth, 6 zeros behind 1 is 1 million. So that will be 1.4 times 1 million, or 10 to the sixth. That's what? That's the answer right here. 1.4. And then you shift this number 6 times. So you get the scientific notation, and then you may do more, as you may write here. Let me move this one up here. So you go further. That would be 1400, and then another 000. So the decimal point was here, and you shifted to this place. So the final choice will be the one right here. Which one? This one is not correct, so will be the one right here. Okay, that will be 1,400,000. 1,400,000. All right, now let's do the last one. The last one, we know 8 times 10 to the 4th power. That's 8 times 1, and there are 4 zeros behind 1. Similarly, here is 4 times 10 to the 8th power. That's 8 zeros after 1. You do the consolation for here there are 4 zeros, and here there are 8 zeros. So 4 zeros will be canceled out. You get another 4 zeros left here. We know 8 divided by 4 is 2. And you have divided by 10,000. 4 zeros after 1. And then you know by mathematical convention that will be 2 times 10 to the 4th, because there are 4 zeros behind 1, and this big number is down below the bar, the fractional bar. So you write negative exponent. Okay? And then you know this will be basically shift 4 decimal points to the left. Or there are 4, this negative 4 tells you there are 4 zeros behind 2, before 2, and you know, including the zero before the decimal point. There are 4 zeros. Then which one? That will be 1 right here. This would be our choice. All right. Okay. Please review this lecture. I'll see you next time.